Okay, college algebra. Topic 2.6. We'll be solving rational inequalities. Rational is basically the idea that we have this big fraction bar. Inequalities that we're using greater than less than signs. Now let's start off with this one. This is 3x minus 6 all over x plus 4 greater than 0. First, I want to observe that this is greater than 0, which means that we're looking for solutions that are actually going to be positive. Again, being greater than 0 means we're looking for positive solutions. Next, we're going to break this down, the 3x minus 6. We're going to put this here, 3x minus 6. And the numerator, we're going to set it equal to 0, but according to what kind of sign we have here. Right now, there's no equal sign on this. So if there's no equal sign here, we're going to say does not equal 0. For the denominator, the x plus 4, let's write that, x plus 4. Denominators, we always put does not equal. Okay, so again, the numerator follows the sign here, but the denominator always has does not equal. So let's solve both of these x's. So plus 6 on both sides here, and we get 3x does not equal 6. Divide both sides by 3, and we get x does not equal 2. We'll solve this side as well. So minus 4 from both sides. We get x does not equal negative 4. So we have two answers, 2 and negative 4. Now we're going to put these two answers on a number line. Okay, and negative 4 would go here, would go first, and the 2 would go here. Okay, now next we need to we'll look at the fact that this is not equal to 2 and this is not equal to negative 4. That means that at the negative 4 and negative 2, we're going to put open circles, which means does not include, because of, again, the not equals to. And lastly, we need to check out these regions. We need to find out which one of these regions have positive answers, and that region will be the one that has our solutions. To check out this area right here, I'm going to use a negative 10 to test that. So if x is a negative 10, we'll get 3 times negative 10, which is negative 30, take away 6. Well, that answer will be negative. If I put a negative 10 for this x, I get negative 10 plus 4, which is negative 6, and that's also negative. So that'll be dividing a negative answer by a negative answer, which would be a positive. So we know that this entire area contains positive answers, which is what we're looking for. Since this is a positive, this area has our answers. Let's check out this area as well. We need a number between negative 4 and 2, so let's use 0. So if x is 0, we have 3 times 0, take away 6. Well, that's going to be negative. 0 plus 4 will be positive, so that'll be a positive answer. So we have a negative answer divided by a positive answer, which will give us negative results, or negative answers. Okay, and this is negative, and we're looking for positive, so this won't be useful. Now let's check out this third side. We need a number after 2, so let's try 10. So we're going to test x equals 10. 3 times 10 is 30, take away 6, well, that's positive. And 10 plus 4, that's positive as well. So you have a positive divided by a positive, which means this area is all positive. So our solutions will come from this positive and this positive area, and we'll write it in interval notation as negative infinity to negative 4, parentheses to represent that open circle, not included, union this side, which is parenthesis again, 2 to positive infinity. Okay, let's try a problem like this again. This time let's try 5x plus 10 all over x squared minus 16. And let's go this time for less than or equal to 0. Okay, first, look at what kind of solutions we're looking for. Since this is less than 0, that means we're looking for negative numbers. Greater than 0 means we're looking for positive numbers. Less than means we're looking for negative numbers. So we're looking for negative solutions here. And I'm going to again take my numerator and write it here, 5x plus 10. And I'm going to look at the inequality here. And you notice there isn't an equal sign here, where here there wasn't. So since it has an equal sign, this will be 5x plus 10 equals to 0. Now the denominator, we have an x squared minus 16. Denominators are always going to be does not equal. So let's write x squared minus 16 does not equal 0. Okay, then we'll solve for these two x's and we'll put it on the number line. So let's start with this one. Minus 10 minus 10, I get 5x equals minus 10. Divide both sides by 5, and x equals a negative 2. Okay, so that's 1. Let's go over here. I notice that this right here is the difference of two squares. That can be solved by factoring. So we're going to make this into two factors, two binomials that do not equal 0. One will be x, square root of the x squared is x, and the square root of 16 is 4. And then we repeat it with a minus sign, x minus 4. Okay, so when we solve for this, we'll get x plus 4 does not equal 0, and the other factor will be x minus 4 does not equal 0. So when I solve for these, subtract 4 from both sides here, add 4 to both sides there, and we get x does not equal negative 4, and x does not equal 4. We have three answers, a negative 2, a negative 4, and a 4. Well, we're going to put all that on the number line. Okay, first we'll go the negative 4 here, then the negative 2 there, and then the 4 here. Okay, now notice here for the negative 4 that's a not equal, so that'll be an open circle. For the negative 2 that's an equal sign, so that'll be a closed circle. And for the positive 4, I'm sorry, here, which is here, that'll be an open circle because it's not equal to. Okay, so now we have 4 regions to actually check. This one, this one, this one, and this one. And we're checking for the parts that are going to be negative. So I need a number that comes before negative 4. I'm going to use negative 10 for my x as a checkpoint. So if x is negative 10, we get 5 times negative 10, which is negative 50, plus 10, which is negative 40. That's negative. Here we'll get negative 10 squared, which is 100, take away 16, which is still positive. So that's positive. So this first one will give us a negative answer divided by a positive answer, which is negative. So this region is negative, which is good because we're looking for negative parts. So this is going to be a good part, or part of our solution set. This area right here, a number between negative 4 and negative 2. Let's try negative 3. So if x is negative 3, we get negative 15 plus 10. Well, that's negative 5, so that's negative. We also get negative 3 squared, which is 9, take away 16, and that's negative. So let's kind of get this positive out the way and make a little negative sign. So we'll end up with a negative answer divided by a negative answer, which means this area is positive and not really useful because we want negatives. Okay, we need a number between negative 2 and 4. Let's try 0. With 0, if x is 0, we get 5 times 0 plus 10. Well, that's positive. And here we'll get 0 squared minus 16. Well, that's negative. So a positive answer divided by a negative answer gives us negative. So this region is negative, which is good because we're looking for negative parts. And after the 4, let's try a number after 4. Let's say 10. If x is 10, we get 5 times 10, which is 50, plus 10, which is 60. That's positive. And here, x squared being 10, or x being 10, gives us 100 take away 16, which is positive. And a positive divided by a positive will be positive. And so we can't use any answers in here because we're looking for negatives. So our solution will be this. This area right here represented by negative infinity to negative 4 with a parenthesis. Union, this area right here, which is closed negative 2 to 4 open. And this is our solution set for this inequality.